This is National 4, National 5 Chemistry, Unit 2, and today we're going to look at some of the reactions of hydrocarbons. So our learning intentions are, as a recap from last time, to be able to explain the terms saturated and unsaturated, and to learn the test for unsaturation and describe the result of the test, and also look at other addition reactions. So saturated means that molecules contain only carbon-to-carbon single bonds. Saturated begins with an S, single bonds begin with an S, so S goes with S. And examples of saturated hydrocarbons are cycloalkanes and alkanes. Unsaturated means any hydrocarbon that contains at least one carbon-to-carbon double bond. And of the hydrocarbons that you've learned so far, alkenes are your example of unsaturated hydrocarbons. So other than looking at a picture of the chemical to see if it contains a double bond, how could we tell whether a compound is saturated or unsaturated? Well, this is done using the bromine solution test, and the bromine solution tests for unsaturation. You need to know and be able to describe the results of the bromine solution test. So unsaturated hydrocarbons, that means hydrocarbons that contain at least one carbon-to-carbon double bond, will decolorize bromine solution. So bromine solution is an orange-brown color. If you add a few drops of bromine solution, sometimes called bromine water, to a hydrocarbon, that orange-brown color will become colorless. If you add the orange-brown colored bromine solution to a saturated hydrocarbon, it will not decolorize and it will turn your solution orangey-brown. So the results of this test, if you add bromine water or bromine solution to a hydrocarbon, if the solution goes colorless, it means it's unsaturated. If it stays orange-brown color, it is saturated. Now, the unsaturated compounds, the reason why they decolorize the bromine is because the double bond between two carbon atoms breaks, and each carbon forms a bond to a bromine atom. And we call this type of reaction an addition reaction. So when it comes to addition reactions, we're going to be able to explain what is meant by an addition reaction and learn how to draw structures for the products of addition reactions. Addition reactions are pretty easy to describe. They are when we add two molecules together and end up with just one molecule. So it's when one molecule is added onto another. These reactions easily happen in alkenes because the carbon-to-carbon double bond, the functional group, is reactive. And in an addition reaction, the double bond is broken. In addition reactions, small molecules add across the double bond. Now what we mean by that is that a small molecule that contains two atoms, one atom adds on to one carbon that used to be part of the double bond, and the other atom adds on to the other carbon atom. So for example, bromine adds across the double bond so that each bromine atom is bonded to each carbon of the alkane, but no longer to each other. And this is how we would describe or draw that reaction. So we've got an alkene, it's got 2 carbons, so that would mean it's called ethene. We add bromine to it, and what happens is that in the alkane, the double bond breaks, and in bromine, the bromine to bromine bond breaks, and what happens instead is each bromine atom now bonds to 1 carbon atom each. So we end up with each carbon atom having only single bonds. Each carbon is bonded to 2 hydrogens, to 1 bromine, and then also to 1 carbon. Now, when alkenes undergo addition reactions with halogens, halogens being things like fluorine, chlorine, bromine, iodine, etc., they produce dihaloalkanes. So here we've got an example. So that first alkane, the longest chain is 1, 2, 3, 4, 5 carbon atoms. The double bond is on carbon number 1, so that is pent-1ene. We see the bromine doing an addition reaction, so the double bond breaks and each carbon forms a bond to a bromine atom each. And we would call that final molecule 1,2-dibromopentane. So that's to show that we've got a bromine atom on carbon number 1 and a bromine atom on carbon number 2. 1,2-dibromo, because there are 2 bromines in the structure, pentane. So another type of addition reaction is adding hydrogen. And this can sometimes be called hydrogenation. So ethene plus hydrogen gives us ethane. So you can see we can do an addition reaction to turn an alkene into an alkane by adding hydrogen. When alkenes react with hydrogen, the product formed is an alkane. And as I said, that is sometimes called a hydrogenation reaction. But if you're asked in an exam, that type of reaction is an addition reaction. So here we have an example where instead of adding a diatomic molecule where each atom is the same, like hydrogen or bromine, we are adding hydrogen chloride. And just as before, what happens is that the hydrogen will bond to one of the carbons and the chlorine will bond to the other. Now this means that there are lots of ways in which we can draw the final compound, and all of these would be correct. So the left-hand side one will always have 3 hydrogens bonded to the carbon, the right-hand side one, as long as you draw that chlorine bonded in any of the 3 possible positions, it's okay. So the hydrogen goes on one side and the chlorine goes on the other. So here are some for you to practice. So I suggest that you have a go, draw the starting materials and the products for each of these addition reactions. Probably pause the video to have a go. So hopefully you have unpaused the video and had a go at those questions. The first one is ethane plus chlorine. And that product is 1,2-dichloroethane. It's okay, you don't really need to name the product, but as long as you've drawn a chlorine on either side, one on each carbon, and shown all single bonds, that's fine. If your chlorine atoms are pointing in different directions, that's also fine. For the next one, propane plus bromine. Well, again, you're adding the 2 bromine atoms across the double bond, so you need 1 bromine on carbon number 1, 1 bromine on carbon number 2. It doesn't matter where around the carbon you've drawn it, as long as there's one bromine and two hydrogens on carbon number 1, one bromine and one hydrogen on carbon number 2, and 3 hydrogens on carbon number 3, your answer is correct. And what we would call that molecule is 1,2-dibromopropane. So here we have butene plus hydrogen fluoride and propane plus hydrogen. So we'll look at propane plus hydrogen first. It's quite easy because you're adding hydrogen across it, so you end up with propane. Now if we go back and look at butene plus hydrogen fluoride, now this is where there are two possible products. Because you're adding two different atoms, a hydrogen and a fluorine, across the double bond, you could add hydrogen to carbon number 1 and fluorine to carbon number 2, which would give you the top product, or you could add the fluorine to carbon number 1 and the hydrogen to carbon number 2. Both of these are correct. And in an exam, you would probably, you might be asked to draw one product, or you might be asked to draw all the possible products. So always remember that when you're adding two different atoms, a small molecule like hydrogen fluoride, hydrogen chloride, across a double bond, the hydrogen and the fluorine can go on different atoms to one another. And those two products are called isomers of one another. So just be cautious that sometimes an addition reaction can give you two different products. And the final type of addition reaction that we're going to look at is the reaction between an alkene and water. Now, this type of reaction is an addition reaction, but it can be called hydration for adding water. And this forms an alcohol. Now what happens in this case, because we've got 3 atoms rather than 2 with water, is that hydrogen goes on one of the carbons and then hydroxide OH, which we'd call hydroxyl, whenever it is on a hydrocarbon, goes on the other side. So hydrogen added to one side and OH added to the other side. And a molecule that contains an OH group, a hydroxyl group, is called an alcohol. And in the next lesson, we will be looking at alcohols specifically. So in this lesson, we looked at using the bromine test, the bromine solution test, to tell apart a saturated and an unsaturated hydrocarbon. The bromine solution test, if the bromine solution turns from orange-brown to colourless, that means you have an unsaturated hydrocarbon. If the bromine water does not change colour and it stays orange-brown, that means it is a saturated hydrocarbon. We then understood that what's happening in the bromine solution test is an addition reaction of bromine across the double bond. And then we explored lots of different types of addition reactions. So we looked at hydrogenation, which can turn an alkene into an alkane. And finally, we looked at hydration, which can turn an alkane into an alcohol.